let's be real for a second. You made a highly complex, mathematically driven decision this morning before you even threw off the covers. Maybe you hit your snooze button. Actually, let's just assume you hit it twice. Well, in that hazy, half-awake state, your brain was actively calculating probabilities. You were weighing up the exact trade-off of being incredibly tired against the precise risk of being late to work. You ran the numbers, arrived at an optimal answer, and made your move. So look, you did math today, and you probably didn't even know it.
Today, we're uncovering the hidden math running quietly and completely seamlessly underneath your everyday life. We're going to explore the math of waiting, the secret sauce of image compression, Newton's cooling law, those spooky content algorithms, and even game theory in sports. By the time we wrap up this explainer, I promise you it's going to completely change how you see your most ordinary, mundane routines.
All right, first up, the mathematics of waiting. Picture this. You're at the supermarket, you're ready to pay, and you have to make a snap judgment. Which queue do you join? I want you to mentally choose right now, literally in this fraction of a second. Option 1 is a line with just 3 people, but they all have full, overflowing trolleys. Option 2 is a line with 6 people, but they're only carrying small baskets. Which one are you walking toward? Instinctively, almost all of us walk toward the left, right? The line with fewer people. It just feels right. But mathematically speaking, counting the number of people instead of the number of items is usually the completely wrong move. And this brilliantly illustrates a fascinating field called queuing theory. It was actually invented way back in the early 1900s by a Danish engineer named Agner Kraurup Erlang, who was just trying to solve telephone network congestion. So the crucial takeaway here is that a queue's length isn't just about a head count. It's all about the variance in service time. You see, scanning 60 items takes vastly more time and introduces far more unpredictability than just scanning 8 items. Supermarkets actually use Erlang's equations in real time to figure out how many tills to open, keeping your average wait below a specific threshold. It is, quite literally, the mathematics of impatience. Moving on to section 2, let's look at the incredible mathematics happening right in the palm of your hand every single time you take a smartphone photo. Think about this for a second. When you snap a picture, your camera sensor captures raw image data. We're talking sometimes 20 or 30 megabytes worth of pure visual information. But when you look at that saved file in your gallery later, it's miraculously only about 3 megabytes. So where on earth does the rest of the file go? How does it just vanish without ruining the picture? The answer is this spectacular piece of mathematics known as the discrete cosine transform. This is the hidden engine roaring away inside JPEG compression. Instead of stubbornly trying to store the exact value of every single individual pixel, it recognizes that images usually have these large areas of similar color and brightness. So it stores mathematical waves, patterns of light. Think of it like music. Instead of writing down the precise physical vibration of every single air molecule in a room, you just write down, hey, play a C chord for 2 beats. So here's how the sequence plays out. First, your camera captures massive amounts of raw data. But then the algorithm exploits a major flaw in human perception. It turns out our eyes are actually terrible at noticing subtle color changes. So it quietly just throws away all that extra color detail our eyes can't even perceive, saving this enormously compressed JPEG. Guys, every selfie you've ever taken is essentially just a Fourier-inspired equation. All right, section 3, Newton's law of cooling. Let's step away from the screens for a minute and bring this back to something absolutely essential, your morning coffee. I've got a classic Socratic dilemma for your morning routine. Imagine you just brewed a hot coffee, but you aren't going to drink it for exactly 10 minutes. You want it to be at the absolute perfect, warmest possible temperature when that 10 minutes is up. Here's the question. Do you add your cold milk immediately, like right now, or do you wait and add it right before you take your first sip? To solve this, we rely on one of physics' most elegant equations, Newton's law of cooling. The absolutely crucial point here is that the rate at which something cools down is directly proportional to the temperature difference between that object and its environment. In plain English, piping hot things lose their heat incredibly fast at first, and then that cooling process slows way down as they get closer to room temperature. So what's the mathematical solution? Add the cold milk immediately. Seriously, doing this instantly drops the coffee's temperature closer to room level. Because the temperature gap between the room and your coffee is now way smaller, the overall rate of cooling slows right down for those next 10 minutes. If you wait to add it later, your black coffee is just hemorrhaging heat at a massive rate. Math literally guarantees you a warmer cup. Section 4, Content Algorithms. Now let's shift the focus directly onto you and the exact experience you are having right this second. Really think about it. How did the platform you're on right now know to serve up this exact explainer to you? How do platforms like Netflix or Spotify guess your highly subjective, super personal taste with such scary accuracy? I mean, it feels a little like magic, right? Well, spoiler alert, it's not magic. And honestly, your taste isn't actually being guessed at all. It's being calculated. This is achieved through something called collaborative filtering. It's a really heavy-duty linear algebra technique. These platforms use vast mathematical grids called matrices to represent you, the user, as a set of precise preferences, and this explainer, the content, as a set of specific features. It maps everything out in a high-dimensional space just to find the absolute mathematically closest match. So these platforms are building enormous matrices with literally millions of data points and applying matrix factorization. The sort of eerie reality here is that the math is finding behavioral patterns and correlations that no human engineer ever explicitly programmed. It just inherently sees the hidden connections in our collective behavior. Finally, Section 5, Game Theory in Sports. Let's move to a super intense, high-stakes environment where math quietly calls the shots. A penalty shootout. The stadium is absolutely roaring. It's just the striker versus the goalkeeper. It's the ultimate strategic dilemma where both players have to make simultaneous decisions in a sheer fraction of a second. So do you shoot left or do you shoot right? Welcome to Game Theory. This is the mathematics of strategic decision-making, which was formalized back in the 1950s by John Nash. The key here is that if a striker favors one side too heavily, the goalkeeper catches on, right? So to succeed, both players have to randomize their choices, but not entirely randomly. They have to randomize them in very precise proportions to essentially make the other player mathematically indifferent to the outcome. Now, if we map out a payoff matrix of the striker's choices against the goalkeeper's, measuring blocks versus goals, a mind-blowing pattern emerges. Economists have analyzed thousands of professional penalty kicks using models exactly like this one. And here is the incredible part. Elite players' actual, real-world shooting patterns match these complex Nash equilibrium predictions almost perfectly. Let's be clear, they aren't out there doing the math on paper. Through pure intuition and practice, they have somehow converged on the absolute mathematically optimal strategy. So let's take a step back and just look at the journey we've taken through a totally normal day. Your coffee cools on this elegant curve. The time you spend fuming in line follows a precise probability distribution. Your photos are squeezed down by mathematical waves. And the very fact that you are hanging out and watching this explainer right now is the direct result of immense matrices multiplying in the background. And the best part? None of this required you to sit down with a pencil and solve a single equation. The brilliant physicist Eugene Wigner famously expressed his total awe at what he called the unreasonable effectiveness of mathematics. He was just mesmerized by the fact that completely abstract concepts, stuff invented by mathematicians out of pure curiosity, so often turn out to describe our messy, real physical world with absolutely astonishing precision. The math was always there, quietly humming along in the background of your life. You were just living inside it. So I'll leave you with this. The next time you pour a coffee, wait in line, or queue up a video, ask yourself, are you actually making a choice, or are you just solving an equation? What mathematical reality do you think we should unpack next? Let me know your thoughts below, and I'll see you in the next explainer.